Hello everyone, welcome back to my lesson. So our today's lesson is based on financial maths, grade 12 financial maths, the introduction to annuities, the present value and the future value. But before we start with the annuities, I want us to go back to our prior knowledge. Um, in grade 11, we actually we were introduced to the simple interest where A is equals to P, open bracket 1 plus I times N, and then the there's a simple decay. A is equals to P1 minus, now they introduce a negative 1 minus I times N, close bracket. And then there's also a compound interest where A is equals to P1 plus I, close bracket, to the power N. And then there's a reducing balance method where A is equals to P1 minus I to the power N. P stands for principal amount. And then there's another formula uh, for converting, and it's as follows: 1 plus I new, open bracket, and then you close to the power M equals to 1 plus I norm, close bracket, to the power N. So these are the formulas that you must know prior, right? Before we even start with annuities. So I will create more videos for grade 11 and even grade 12 so that now this can be a pattern. So you'll start by um, understanding the financial maths of grade 10 and then grade 11, and then you get to grade 12, right? So I'll make sure that I create a lesson based on that. But for now, I want us to focus on term 3, which is our financial maths introduction to annuities, because right now we're on term 3. So let's move to our example. So on our example, they are saying for grade 11, usually in grade 11, they can just say a payment of 500 is made into savings account if the account offers an interest rate of 5.5% per annum compounded monthly. How much will have accumulated in the account after a year, right? Perfect. So normally for this, we use this future value formula, né? Which is our compound interest. Where A is our principal amount, that's 500. Yeah? And then you have your 1 plus. Now we need our interest. So that's 0,055 divided. Remember now, they said compounded monthly, so which means we have to divide by 12 there, right? And then the number of years, we have 1, but now compounded monthly times 12, right? And then now we have to get our, and then you'll get your value there, right? And then you get your final answer. So this is just a recap, right? This is just a scenario for grade 11. It's just a scenario for grade 11. We are not focusing on grade 11. We are focusing on grade 12, the annuities. So now now for grade 12, they can come with the similar situation, right? The similar situation. Now they're saying equal payments of 500 are made in a savings account at the end of every month for 1 year, right? Now they're saying equal amounts. So now these are what? Our monthly installment. Every month they pay 500, 500, 500 at the end of every month. So they're consistent. They didn't just made one payment into a savings account. Now they're making equal payments of 500 every month. That becomes what? A sequence. And now, if the account offers an interest rate of 5.5% per annum compounded monthly, how much will have accumulated in the account after a year? Right? So now, how do we actually answer this question? Now, it is important to note this. The first thing, the last deposit on the 31st of December will not earn any interest. So the last deposit, our last deposit would not have what? The interest. So this becomes our 500, which is our last deposit. This deposit will not have, or will not rather, earn any interest. Right? Now, the 11th deposit, deposit number 11, on the 30th of November will earn an interest of 1 month. I hope we are together on that one. The 11th payment will only earn the interest of 1 month. So now you have your what? Your 500. 1 plus, so this is the interest. The interest is 1 plus 0, comma 0.55 divided by 12 to the power 1, because it can only earn the interest for 1 month. And then it continues like that. The 10th month, it will only earn the interest for how many months? 2 months, right? 31st of October. 31st of October, then that deposit will earn an interest of 2 months. So we'll say plus 500, 1 plus 0.055 divided by 12, earning the interest for 2 months, ne? Sorry. And then plus. So this becomes a series. It continues, right? Up until where it will earn the interest of 11 months, where it will earn the interest of 11 months. So this is the what? Last deposit. This is the 11th deposit. This is the 10th deposit. And then this becomes our first deposit. Right? Now, if you can check this whole thing here, this whole thing here, it forms a geometric series. It forms a geometric series. And with that being said, we can now say our A becomes 500, your R is 1 plus 0.0555 divided by 12, right? For how many terms? 12 terms. Perfect. Now, the reason we are using 11 there, it's because it's because the last deposit will not earn any interest. Only the first deposit to the what? To the 11th deposit will earn the interest. And then now, from here, we need to use the SN formula now. We're substituting, né? Now we need to use the SN formula. Our SN from series, you have your A there, R to the power N minus 1, all divided by R minus 1, right? Now, sum of 12 terms is equals to our A, that's 500. Our R, your R, this is our R. You have your 1 plus 0, 0.055 divided by 12. And then you end there, that's your 12 minus 1, all divided by R minus 1. So your R again, you have your 1 plus 0, 0.055 over 12 minus 1, right? Let me just remove the brackets. Let me remove the brackets. Minus 1. Just like that. So now you end up having something like this. 1 and 1 will cancel. So this becomes your 500. 1 plus, okay, let me just create space. So now you are having your 500 right? Becomes your 500. 1 plus 0, 0.055 divided by 12. And then there's 12 there, minus 1, all over 0, 0.055 over 12. Now, this becomes the formula of future value. Now, this becomes the formula of future value. I'm not interested on our final answer. I was just deriving the formula of future value, which is our annuity. So this becomes the formula of future value. And the formula of future value is given as follows. The future value FV given as X for monthly payments. And then you have your 1 plus your I, interest, N, above payments. And then interest I. Now, monthly installments, 500. 1 and 1. Interest, this is the interest for I. Minus 1, minus 1. And then interest, interest again. So now we've derived the formula for the future value from grade 11 information. I believe that you've understood this part, right? So now I want us to label now the formula. I want us to label the formula. So F, your F stands for your future value. Your F stands for your future value. X value of the installment. Usually paid monthly. Okay, and then I, interest rate, we specify not in percentage, not in percentage. And then lastly, N, as I've mentioned earlier, this is just the number of payments. Number of payments. It can be deposits, number of compounding periods, right? So number of payments is deposits, or we can just say number of compounding periods. Right? So yeah, so that's it for today, guys. So on my next video, I will try and use the formula now to answer the questions. For now, I was just introducing the formula and try to label it and show you where does it come from and test the prior knowledge of grade 11, all of that. And then on my next video for grade 12, I will try and apply now the formula and try to answer certain questions. Thank you so much for watching this video. Bye.